In this work, we present SpaText, a representation for controllable image generation. Imagine you could generate an image by dipping your digital paintbrush, so to speak, in a black horse paint. Then, sketching the specific position and posture of the horse. Afterwards, dipping it again in a red full moon paint, and sketching in the desired area. Finally, you want the entire image to be in the style of the Starry Night. We aim to generate an image that complies with all of the inputs. Given that interface, we can reuse the same scene layout with different text prompts. Current state-of-the-art text-to-image models are able to generate convincing results of unprecedented quality. However, converting a mental image into a real image is practically impossible using text alone. Over the recent years, large-scale text-to-image datasets were curated by the community, fueling the tremendous progress in this field. However, these datasets do not contain local text descriptions for each segment in the images. We propose to utilize the current image text datasets along with a pre-trained segmentation model and a clip model. During training, we start by decomposing the image in two segments, using a pre-trained segmentation model. Then, we extract the clip image embeddings from each segment separately. Lastly, we form the Spatio-Textual Representation by tiling those embeddings spatially in the corresponding shape of the input segments. That way, this representation contains both the semantics of each segment and their structure. During inference, instead of an input image, we get from the user the raw segments, along with their corresponding text description. We start by extracting the clip text embeddings. Then, in order to mitigate the domain gap between the clip image embeddings and the clip text embeddings, we train separately a designated model, named the prior model, that translates between those embeddings. Finally, we tile those embeddings the same way we did during training. Classifier-free guidance is an inference method for conditional diffusion models that enables trading off mode coverage and sample fidelity. It involves training a conditional and unconditional models simultaneously and combining their predictions during inference. In order to extend classifier-free guidance to our multi-conditional case, we suggest two variants. The multi-scale variant involves calculating the direction for each condition separately, then linearly combining them using a different guidance scale per direction. However, the execution time grows linearly with the number of conditions. Hence, we suggest a faster single-scale variant that involves calculating the joint direction for all the conditions. Then, extrapolate towards this direction using a single scale. The slower multi-scale approach enables additional controllability. For example, given a local scene of a brown horse, along with the global text of a sunny day at the beach, we can use equal guidance scales to get an image that corresponds to all of the inputs equally. But we can also diminish the scale of the global scene, gradually removing the sea background. Or alternatively, diminish the scale of the local scene, gradually removing the horse. Our method outperforms the baselines both qualitatively and quantitatively. In addition, we found our method to be robust to find subtleties in the input mask. Given a general animal shape, the model is able to generate a diverse set of results while preserving the pose. For example, the model created the cat's ears and the goat's horns even though they are not a part of the input mask. Here are some additional results produced by our method. For more information, please read our paper.